Okay, let's get started. So if I'm reading this to you and you're watching me on the board, this means my daughter's sick today. So this is going to be your lecture for today. So today we're going to go through scale diagrams and currency exchange. I would say most of all, don't be afraid of this because it's just ratios. It's just learning how to organize ratios. So before we start, let's go through the regular thing. Simon, put your phone away. Alora, yes, I'm happy to see you. Zach, wake up. Bladen, I know you probably know how to do this already, but bear with me. And I'm glad Nicole's excited. Okay, let's go, Kayla. And that was an email arriving to me. So let's go through this sheet you have. And I'm going to go through it slowly, so hopefully you have a chance to catch up and everything like this. So a scale diagram is a drawing that enlarges or reduces the actual size of an object. So a good example of a scale diagram is a map. So that would be reducing. Something that would be enlarging would be, I think even instructions of some kind might tell you how to enlarge things. Okay. So a drawing maintains the same proportions. So this means that a scale diagram keeps the same proportions whether you're going up or down the scale. So if something is twice as big when it's small, if you enlarge it, so if you have two items, item 1 and item 2, and one's twice as big, it's still going to be twice as big if it's smaller or larger than the original item. Okay? So that's where the ratios come in. So how to do the formula is as follows. I like to put my unknown item on top. Oh, come on, click. So my unknown on top and my known for that item below. Okay? I'll line this up here. And then I'm going to make that equal to the known partner to my unknown over the known partner. This seems really confusing right now, but once we start working through it, there we go, partner. Once you start working through it, it'll all make sense. Okay? So the first question here says, a diagram of a boat has a scale of 1 centimeter to 4 meters. So that means the diagram, for every centimeter on the diagram, the actual size is 4 meters. So I want to calculate the actual length of a boat if the diagram says it's 5 meters. So what I want to do is I'm going to set up my unknown. So let's make x my unknown. That's what I'm trying to figure out. Its partner on the diagram is 5 centimeters. So it's 1 over 5. Okay. I'm going to have to write this as a fraction. What I'm actually writing here is a fraction. So as you write it down, write it as a fraction for me. I'm going to make that equal. Now, I have the centimeters on the bottom, or the lower scale on the bottom. So let's put 4 meters on top, because I'm actually trying to find actual size, over 1 centimeter. So now I've created my fraction and my ratios. Okay, so x over 5 equals 4 over 1. So the first thing we do is we divide this side first. We're going to divide this side first, and that is the wrong. I highlighted it white. Let's highlight it there. Okay. So I'm going to divide this side first. So that's going to give me x divided by 5 equals 4 divided by 1 is just going to be 4. Okay. Then my next step, I have to bring that 5 over. It's a divide on this side, so when it comes over, it's going to become a, Kayla, I'm going to wait for you to tell me. It's going to be 4 times 5. So that would mean x is going to equal 20 meters in the end. 4 times 5 is 20. So my actual boat is going to be 20 meters. And I could write a little statement here, therefore the actual length of the boat is 20 meters. Boom. Right. So next. So as you saw there, I put my unknown on top, my unknown partner being the 5 centimeters on the bottom. Then I match up my other ratio to match. So meters on top, centimeters on the bottom. So let's calculate the diagram length if the sailboat's actual length is 2 meters. Right? I'm going to do it on the side, then move it in. So my x is here. And then I'm going to put on the bottom 2 meters on the bottom. So what's its partner? Okay, so I have meters on the bottom. So let's go 1 centimeter over 4 meters. All right, so here we have our ratio, 1 over 2 equals 1 over 4. So what's my first step here? Let's give Bladen the first shot at this. So my first step here is to go 1 divided by 4. So 1 divided by 4 is going to be 0.25. Then I have to isolate the x here. So I would divide by 2. So I'm going to move it over and it will become a multiply by 2. That little star I'm putting up is multiply by 2. So x should equal, something wrong with my math here. Oh, sorry, that's 12. I should say 12 there, not. That's supposed to say 12 in your note. I might have accidentally erased the 1. Alright, so x over 12, boom. So 0.5 times 12 is, 0.25 times 12 is 3 meters. 3 centimeters, sorry. Therefore, the diagram of a sailboat is 3 centimeters long. Okay. So there's my answer right there. Now, as we go through this, if I get going too quick, just pause the video, and then once everyone's caught up, we can restart it again. So determine the scale that is used for each of the following drawings. So when saying determine the scale, we're looking at figuring out what we're enlarging or shrinking it by. Okay? So in this case, to determine the scale, we are just going to take a peek at the drawing over actual size. Okay? So an actual horse is 1,500 millimeters tall. The drawing is 150 millimeters tall. So this time we're going to go, so we're going to go actual over, drawing over actual. Okay. So in this case, the drawing is 150 and the actual is 1,500. So if we go 150 over 1,500, so 150 over 1,500, you're going to get a 1 over 10. Okay. So one of these, you times 150 times 10, you're going to get this. You can write it that way or like this. Okay. So let's take a peek here. That's the first one. I'll move that over. And pause and kind of take it in. Oh, I forgot my statement. Therefore, the scale is 1 millimeter to 10 millimeters. So we have to figure out the scale for the next one. So remember, you're going drawing over actual. Okay. And because Alora asked, I'm going to wait here for a little bit and see if you can figure it out first yourself. So whoever has the mouse, please pause and we'll wait. Okay, thanks Alora for waiting. And let's go on to our drawing. So what's the actual drawing size? The wingspan of the fly in her drawing is 10 centimeters. The actual fly is 1.5 centimeters. Okay. So we are going to create a ratio, we're going to divide each one by 1.5. So you're going to divide each one by the smaller one. So divide top and bottom by 1.5. Who spelled bottom that way? Horrible. So if we do that, we are going to get 6.67 over 1. Okay. Or, if we want to write it this way, 6.67 to 1. Therefore, the scale is 6.67 to 1. So in this case, would you deem this a enlargement or a reduction? With the case with the fly, it would be an enlargement because the fly is smaller in actual size, right? The fly's actual size is 1.5. We're enlarging it to 10. For this one, we're making a drawing of the horse and we're reducing the horse in size. So let's take a peek here. Given the diagram below, approximately how many times taller is the Eiffel Tower in comparison to the Great Pyramid of Giza? So let's take a peek at what we're going to do here. So how many times taller? So let's set our unknown as x. Okay. And let's put under it 1 . So this is the size. We'll make x equal. I'll put a little. So x is going to equal the Eiffel Tower in comparison to our Eiffel right here, in comparison to our Giza. Okay? Then we're going to put the actual sizes up. Right? So if we take a look at our chart, the actual size of the Eiffel Tower is about 4.25. And the actual tower of our pyramid is about 1.25. So our first step in solving this is to go 4.25 divided by, remember if it's a fraction, that fraction just means divide, by 1.25. So x over 1 equals 3.4. Then we need to isolate for the x here, so we need to bring the 1 over. So it's a divide on the side, we're going to bring it over, it's going to become a multiply. So x equals 3.4 times 1, and 3.4 times 1, of course, is 3.4. Therefore, the Eiffel, let's spell it right this time, is 3.4 times taller than the pyramid. And how many spelling mistakes can I make? That one's a pretty tough one. The ones we'll concentrate on more are these ones up here. So, let's say you're traveling abroad. Okay, so every country has different money. So you may need to exchange your money to a different currency. And it's nice to know how much currency you'll need to going forward. So let's go here. So we're heading down to the States, right? Kayla, what are we going to go buy in the States? Kayla said shoes, I think, if I'm not mistaken. So let's go buy some shoes in the States. So suppose you're traveling to the United States. The bank will exchange $20 Canadian for 17 US. How many US dollars can you get for $225 Canadian? So let's set up our ratio. So we're going to put our unknown on top. Okay? So our unknown will make x. Below in our fraction, we're going to put how much its partner. So in this case, how much Canadian money we have. So we're going to exchange $225. Right? So right now we have American over Canadian. Right? So we have American money, because that's what we want to know. American money over Canadian money. So when we set up this second part of our ratio, let's do the same thing. So we have American up top, so let's put our American that we know, $17 over our $20. And the first step to this, hopefully everyone knows so far, is what? Who should I ask? Let's ask Robert. And of course Robert would get it right with 17 divided by 20. Let's go x over 225 equals, I need my calculator. Pause for 2 seconds. I can pull my calculator up on my other screen. $17 divided by 20 equals 85. $0.85. Then our next step is going to be to isolate this x. So we have x over 225, so we need to bring it over. So it's going to become a multiply. 0.85 times 225. And that is going to equal 191. So x is going to equal 191.25 American money. So that means my $225 will buy me 191.25 American. So let's wrap it up with a therefore statement. There's my cash here. 25 USD. So USD is US denomination for 225 Canadian. So, next question is, if you return to Canada with $15 US, how much would you get? How much would that be in Canadian dollars? Okay, so now we're looking for Canadian dollars. So let's make that our X. I'll put a little C and D here. We're going to make it over our $15 US. So I'm going to give you a second to figure out your second fraction here using this original 20 over 17. What's going to be on top? What's going to be on the bottom? So since we had Canadian on top on the left-hand side, we're going to put Canadian on top on this side. So it'll be 20 divided by 17. And we started off by dividing. So 20 divided by 17, as I do the calculation on the other side of my computer, is 1.18. 1.18. Now we have to isolate that x. So we have x divided by 15 right now. So let's take the 15 over to the other side, and it becomes a multiply. So I go x equals 1.18 times 15. That's going to result in my answer being times 15, 1765. 17.65. Oh, I forgot my cash. Canadian for $15. The one assumption you would make here, which I'm not really concerned with whether you make, is that, so you're assuming the exchange rate does not change while you're gone. In all actuality, the exchange rate changes daily, if not hourly. So it goes up and down depending on a whole bunch of things that we have no control over. So that one's done. So next one here, example 2. So if currency is exchanged for $1 Canadian equals 0.74 US, how much is $1 US in Canadian? So let's start with our ratio. So let's put our unknown on top. So the unknown is going to be the Canadian dollars. And if it helps you to write out what your unknown is, so right now I'm writing unknown's Canadian, and it's going to be over 1 USD. If you want to write this every time, it'd be perfect. Even up here, I could go back and I could write actual over diagram. Right? That way, when I go on to this side, I know which one to organize here. Okay, I'm going to put actual on top. So the actual is the 4 meters. The diagram's 1. Right? So the more you write this, the better it will work out for you. Let's go back here. So I have x over 1. So that means I have to put my Canadian up top. So I'm going to put 1 up top, and its partner is 0.74. So, and a little hint here, if you ever have x over 1, that's the same as saying just x, because anything divided by 1 is just that item that's on top. Okay? So, because we have x over 1 here, I'm just going to reduce this, take away a step, and just go x. Then we're going to go 1 divided by 0.74 equals 1.35. 1.35. Therefore, $1 US is worth 1.35 Canadian dollars. All right, let me go back, put the cash in here, because I know if I don't, Bladen will be all over it. Whose name hasn't I said yet? I don't think I've said Devin's, because Devin will be nice and quiet and probably looking at his phone right now. Hopefully he's keeping up. All right, so how much would a $89 watch in US cost in Canadian dollars? So this is a good idea. If you ever see sales in the US or you go shopping in the US, it may sound really good, but sometimes with the exchange rate, the price isn't as appealing as it might be. So how much would an $89 American dollar watch cost in Canadian? So we're looking for Canadian here. So let's write X, C, and D, and its partner is the $89, and that is the US money. So my second part of this is going to be the exchange rate. The exchange rate again is 1, because we're putting Canadian on top, and 0.74 with the American on the bottom. Then our first step is, of course, who should I ask? Who have I not said anything to? And if I forget anyone, they're going to be horribly insulted by it. We asked Devin. Kevin's back. So 89. What do I do, Kevin? First, I always divide. So I go 1 divided by 0.74, and we know from above that is 1.35. Now I have to isolate that x. So right now it's x divided by 89. So we're going to go, it's a divide on this side. When it comes over, it becomes a multiply. So 1.35 times 89. And that x is going to equal $120.27. So it sounds like a really good deal, an $89 watch, but once you do the exchange rate, it may not be as good a deal as it looks. It still might be, of course, but sometimes it's not quite as good. Therefore, we look here, $89 watch in the US will cost you 120 Canadian. All right, so that's about it for today. You have a worksheet to work through for the rest of the period, and you can go on the OneNote and find the answers. I will also put, I'll make an answer key and give it to the teacher as well. Okay, have yourself a wonderful day, and I will see you tomorrow. Tomorrow's review, Friday's a quick quiz on ratios and percents. Okay, have a great day.